Welcome to this video 3 or session 3, wherein we are going to give the inputs. Okay, but before that, if you have done the subscription, I'll be happy. Or otherwise, if you subscribe, the YouTube channel where I'm uploading this particular videos or learning tutorials in DWSM will be added advantage to you. That means you'll be able to immediately see the updates I have provided. Okay. Now see, now this particular in any simulation exercise, now what is important to us in any simulation exercise, if I say simulation, if I say simulation, I'm only interested in giving inputs. I'm not giving outputs. Inputs with respect to the streams, with respect to the equipment. That means if you give inputs to the inlet streams and the equipment, that means that will have to work according to our simulation understanding. Okay, right. So in this video, already in the last session, we have set up our what you call heat exchanger. Now this is one inlet stream which is going to the tube side. This is another inlet stream which is going to the shell side, that is styrene. Our heat exchanger, this is our heat exchanger. We require to give inputs with respect to these lines. And after giving inputs, you can see this particular value, this is styrene in, and this particular value toluene in. This is pressure and this is mass flow. And what is the values? How much is the values we need to enter into this particular particular is that? So we have already seen is that. Let me actually okay. So now let us go to inlet streams and then let me save this first. As per the previous videos, you can see that we have to give certain inputs. Let me save this first. Now I double click this toluene input, and you can see this is given and status is not calculated here. And the temperature and pressure, we have taken temperature and pressure. We have not taken any other thing. We are taking only temperature and pressure. And this is compound amounts. We should say this is toluene. I make this as composition 1 and then make this composition size as 0. And don't forget to accept this. And then come back to this particular place. And what is the temperature with which our stream is entering? That means toluene is entering at 100 degrees Fahrenheit. So I will say 100 degrees Fahrenheit and press enter. And the pressure with which it is entering. What is the problem specification? And the pressure is toluene enters tube side, and this is 90 psi. The toluene is 90 psi. That is what is our problem specification. And the mass flow of the toluene is 1,25,000. 1,25,000. 3 zeros. So let me click here, and then toluene mass flow 1,25,000. Now automatically you can see the other data is getting updated. And this is vapor phase mole fraction is 0 degrees. That means it is entirely liquid. So we have specified the toluene flow. That means this particular stream we have defined its properties. That is flashback is temperature and pressure. Temperature is 100 degrees Fahrenheit. Pressure which is entering is 90 psi. Mass flow is 1,25,000 as per the problem specification is mentioned in the textbook we have taken. Now the styrene, this is styrene. Double click on it. See, still it is red in color. That means inputs are not mentioned. Now first go to the compound amounts. First make the toluene as 0. Make the styrene as 1 and then accept it. See, automatically with the given conditions, it has given certain base calculations. Now I'll go to the styrene in again, but the pressure at which this styrene is entering is 50 psi. This should be temperature is 300 degrees Fahrenheit. So 300 degrees Fahrenheit. And the pressure is 50 psi. So 50 psi. And the flow rate, mass flow rate is 1,50,000 as per the problem specification. So this is 1,50,000. 1,50,000. So this automatically you can see it is changing in pound moles per hour, ATP per hour, and it is giving specific enthalpy, specific entropy. In this case also vapor phase mole fraction is zero. That means it is entirely liquid because it is less than the boiling what? The boiling point temperature of the styrene. What is the boiling point temperature of the styrene? Let us go to the styrene and then new selected compound. And then let us check the what is boiling point. What is boiling point? 293 Fahrenheit. That means it is more than that. See, whatever we have specified, it is more than that. But what is the pressure? What is the pressure here? Pressure is 50 psi, that is more than atmospheric pressure, though still it is retaining as liquid state. So if the pressure, if I give it as a 1 atmosphere, that means 14.7 in psi pounds per square inch, it should be obviously 14.7 if I'm right, 14.7. Is it 14.7? Yes, 14.7 should be psi pounds per square inch or 29.9 inch cube, I suppose. But let us stick to this. It is if you definitely it is not atmospheric pressure, it is greater than atmospheric pressure. That means even the temperature is more than the boiling point, still it is actually see, it is vapor phase mole fraction is zero, that means liquid. If I'm making this as 14.7 psi. See, 1 atmosphere is how much? Let me ask, let me go to the deep sea or rather Google, and then let me ask 1 atmosphere is equal to how many psi? I'm asking 1 atmosphere is 14.7 psi. Obviously, I have taken Google help. It is saying that means at atmospheric pressure, if the temperature is greater than its boiling point, see vapor phase mole fraction is changing to 1, which is vapor. Now you can see here, if I look at this phases also here at the bottom, this is coming as, it is coming as vapor phase only. So if I go to this place and then results and then phase properties, you can see this is vapor. Vapor phase mole fraction is 1. So mixture properties and then all these properties are estimated as it is. See, this is vapor now. There is no liquid point. Now if I remove this 50 and then enter again, now I come to the results. Now you can see there is a liquid, but there is no, in the results, you are not finding any vapor tab. Okay. So in this video, what we have done is we have specified the inlet conditions with respect to the streams. Okay. See, now you can see this is Tolvin in. That means we have specified the temperature here, the pressure, the mass flow. And with respect to the styrene, we have specified with respect to the styrene, the temperature, the pressure, and the mass flow. But still, we have not told anything to calculate. We have only defined the inlet conditions, that too with respect to the streams. And very important or very helpful part we will see. Let us go to the settings and then let us go to the settings and then you find here what do you call the object properties. I say display temperature, display pressure, and display mass flow. Then I click this here. Now you can see in the each stream, it is getting defined. See, let me actually put it like this so that it will be easy for us to make out. So this is the tube side and this is the tube side. Let me make it out more this thing. Now you can see in the flow sheet itself, we are able to look at this particular properties. But this is becoming a little lengthier, but to understand better, we can actually make it out like this. These are identified as a object properties in the settings. Now this is stream in and this is stream out. If you take the what you call directly the printout, you will see all these particular values directly here. You can see the temperature is measured. You can see the temperature in the stream in You can directly see the temperatures, how it is being reflected here. So this is temperature, this is pressure, this is flow rate. Now you can see this is thermometer, this is pressure gauge, this is a pipeline. So this is the beauty of this particular feature in the DWC. Yeah, hope you have understood in what way we have to define our what you call the streams, input streams. I have not yet defined heat exchanger part. We need to define heat exchanger part, that we will do in the next video.